Okay friends, today we'll see another lessons on the blockchain and how is it implemented uh, in our software verification software which we are developing web portal. So in this case today we'll be covering each and every aspects of blockchain network, starting from writing the solidity code to compiling the code and then deploying it onto the network, and also other related accessories like writing code and all is just one part of it. But after deployment there is a verification of the deployed contracts that we'll see, and then we'll see how we'll get the information from Morales or Insura, which acts as a node to interact with the Web3 network. And all the work which we are doing will be done on BSC testnet. So BSC is Binance Smart Chain, just like Ethereum, Polygon, Avalanche. There are a number of chains onto the blockchain network. So we can follow any one of these depending upon our interests and learning. And obviously the first and foremost the main difference between different network is it's about TPS, transaction per seconds, like how fast a blockchain network is able to verify a transaction. Because in the network, the verification, I've already talked a bit about validators in my last lecture. So validators are the backbone of our network. So they need to be fast enough, and they should not be a bottleneck in validating a transaction, because unless and until a transaction is validated, it is not uploaded onto the network. So that TPS, transaction per seconds, play a very huge role here. So Bitcoin has a TPS of less than about 10 or something. Ethereum of 15 or 100, I don't know. Tron is of about 2000, and so forth, and so on and so forth. So it keeps on increasing. People are rewriting the codes, people are doing some experimentations, and then increasing the number of transactions in the so that it increases number of transactions in the network. Apart from this, there is one more important thing we should know about is the proof of work and proof of stakes. Likewise, there are a number of proofs, and proof means for the validation purposes someone has to do some kind of the computers has to do some kind of calculation to validate a transaction, and that's what is happening in mining. Like it does some calculation, the GPU works, performs some calculations, submit onto the network, and there are simultaneously hundred thousands of nodes doing this mining operations. The one which is fastest will be able to grab that, validate first, and then grab that piece of cake, you can say that. And then other will they'll again be doing the same thing, but they may or may not get. Similarly, now since there was a talk on the consumption of electricity, the proof of work is now migrated onto the proof of stake in Ethereum, and that says that you don't need to do mathematical calculation to validate. You just need to have a certain number of coins in your network, in your account, and you can just take it for the validation purpose. So you see, just by changing a bit of algorithm, they are able to physically save electricity and hence the climate. So how, like just by changing the algorithm, they are giving a complete new horizon to this blockchain network. So this concept keeps on evolving. There is something like proof of hard disk kind of, where they'll plot some kind of graphs on your hard disk. SAS hard disk is needed for that. So there are a number of things, and it keeps on evolving. So what right now we are doing is we are working on a BSC network, Binance Chain Network, and it's just like a clone of Ethereum one, but it's a completely different. So if you see the interface of both, you'll not find any much difference. So let's see that. So as you can see, we have both Binance. Okay, so this Binance Smart Chain Explorer and there I'll open it. There is Ethereum Blockchain Explorer. So likewise, visual appearance, they both are different sites, but they have same code working behind, and like the presentation for this is same. That is what I can say, and they are similar in a number of other points. So it is good to know that there is not much variation between these two. So if you work on BSC network, you can easily deploy something on Ether network and all. But since then a number of other networks have also come up, and they have some little higher differences between the already existing. And Ethereum and Binance were early in the fields, and right now people are developing more and more sophisticated algorithms with some higher level of smartness, or you can say the achievements. So you see, Ether price is about 1200 US dollar, and you need to have at least 32 Ether to stake or to earn more Ether. So if you have money, then only you can earn money in this particular case. And if you don't, you cannot earn money, because proof of stake is in work here. Similarly, in Binance Delegate, okay, it's not there. So yeah, Binance price is about 270 degree market cap. You can see it's huge. Again, it's also market cap is huge. It may be Ethereum may be in second or third number, and Binance maybe somewhat down. So we can see the gas prices. You can the gas prices and transactions. 52 TPS transaction per second is of Binance, and this is 13 TPS. That's what I was talking about. Transaction per second. You see, Binance is a bit more faster than Ethereum, and that's why the gas charges is a bit slower. Like you for registering a transaction, you need to pay about 0.03 dollar as the charge, and here you'll need to pay about 0.52 dollar. So this was because of the limitation of network, that if you need to perform any transaction, you need to just pay more. You will be able to perform your transaction faster, or else it will be stuck in queue, and then you'll have to wait for maybe minutes and hours or day, unless and until it is executed. So this TPS, this gas price, and in blockchain network, in both the things, and we do have blocks here. Blocks is something, a set of it has all those information transactions embedded into it. So that is what, and it keeps on like a block is generated after every 6 minutes or 10 minutes for Bitcoin, and similarly it is generated in Ethereum and BSC network, BSC coin. So that is all fixed. How fast a block will be generated, and once a block is generated, how many coins are released into the network to the miner, basically. So that's about this blocks. And you see the average transaction, Ethereum transaction history. It's about 1.3 thousand, and in Binance it's a lot more. Yeah, and I also prefer Binance because if you have to do something on test network, it will only cost about a few rupees rather than 10, 20 rupees or 30 rupees that's shown in Ethereum. So having known all about all these, let us look at one particular transaction and try to understand what it is. If you see this is the address. It may be address of individual user, or it may be address of a contract. I'll tell you more about contract, and we'll be dealing with it sometime later, like in this lecture only. But address is something like address, like you have an address of your home. Here you have an address of your on the network. So this particular address on Binance chain, BSC network, also corresponds, like you can have it on other chains also. Like yeah, this is having on Arbitz, Scans, Rankabase, Testnet, and then Ethereum also you'll be able to get that. So that interchain linking is also available here. So this the balance of this particular random account is about $0.214, which corresponds to 50 BNB, which corresponds to $58, and the guy has so many number of coins. So these are coins. So something like this will be also developing. A coin like this will be also developing, and will also have. Let us look at this coin. So a coin like will be developing a token, a coin which will have a contract address or decimal, and then will have a total supply and number of holders, and then the market value, like it has so many number of market value. So this is how it is done in blockchain. So you see the information like corresponding to this block number, this particular transaction is embedded in this block number, which took about 4 minutes earlier. And if you can see that in this particular thing, yeah, in this particular transaction from this particular address, a contract was okay, this is dead. So this number of coins or something was burned or something. So it's not a simple transfer in this particular case from one account to another. It was to the dead account. That's what it is showing. So that happens. That is okay. Secondly, we can see that this particular block's confirmation, like this particular transaction and the block is being had about 116 blocks confirmation. That information is already stored in so many number of blocks. So here then this is the details of what is happening. This particular function was called, and this particular for to and from address was invoked, and you get this fee burned. So this everything is written somewhere in the contract function, which we'll see. Okay, so that's it about the introduction to the network, different kinds of network, and this is typically same here also, like so many number of Ethereum. Yeah, see this particular address has about this many number of Ether corresponding to $336, and it has this coin corresponding to about $30,000, and then $30,000 of this particular coin, so of a particular guy. Okay, so that is how it happens. So we can see the balance, but we'll not be able to know who this guy is unless and until he links his bank account with this particular address. So that's the anonymity is maintained in blockchain. Like you can see the balance, but you'll not be able to know who the person holds, who the person is, and more about him unless and until he reveals it. So we can see this particular address is also present on Etherscan, BSCScan, Polygon, FTM, RBAScan, Snowtrace, Goerli, Treasury. So this is all inter-network availability of account address is present. So that's make again this particular net blockchain concept very interesting. Now we'll move on to next thing, and we'll see. Since we are working on BSC testnet, we'll be first looking for the nodes, free of course, which will provide us the gateway to the network, because the Web3 API, we will not be able to store or directly interact with this blockchain network like that, because we don't have a copy of that particular network on our PC. So if I were to have set up a node, I'll need a very large system with very high compute power, and then download all the terabytes of information, and then keep it running 24/7 to sync it with the central system. But here that's not possible. So we'll connect to someone who does like the company obviously, who gives us the API to interact with the blockchain network, and through their stored copy of the system. So we'll see there are a number of websites or companies working in this, like Infura, Morales, QuickNode, but we'll be looking something which is best for this BSC testnet. Let us look for the quick node. Here we can see this particular node provides us with the APIs to contact with the blockchain network. Since I'm already logged in to this particular website showing endpoint, the dashboard, or in other way, you'll have to create your own account and then verify your email ID and then create an endpoint. So here there are a number of options we see, but we'll be dealing with just this endpoint. Create some endpoint. So we'll see this API. Yeah, you see this API. This has HTTP provider and WSS provider. So we'll need to copy this. We'll copy this and paste it in our Python code. So this is one thing which is of use. We see here this is our HTTP provider, which will be copied to, which is already copied here, BSC testnet, then discover, quick node, and so and so. So earlier I was doing in Ropsten and Infura, but since it is deprecated, I've migrated to BSC testnet, which is provided by this quick node. So other things will be again talking about, but for now this is the place where we need to feed the information of third party. Now that we have this Web3 API, we'll just move on to the next one, and that is about MetaMask. So MetaMask is the wallet basically. So you can think it up of about like you have some money and you can keep it in your wallet, physical wallet. Here in MetaMask, if you have some coin and you can keep some like you can transfer your coins to this particular wallet, and then there are exchanges just like DAO and SGX and Nifty and BSC NSC. Here also in blockchain network we do have exchanges, and that exchanges is about like if you keep your money there, they'll charge you a few bucks, maybe 10, 20, 50 rupees, but wallet is free of cost. Like you can store your money in your wallet, and you just need to remember your passwords so that in future if it is uninstalled, you can directly install it or log into your wallet and transfer your money. So let's first install this MetaMask. So I have installed this MetaMask here. It looks like this Fox browser. So I'll just click it here, and since I already have an account with a particular, this is my address, and this has about 0.2234 test BNB. We are on test BSC test network. So by default it will be on Ethereum mainnet, and since I have nothing or 0 ETH balance, I'll have to add network, and in adding the network it shows something like this. So we'll add Polygon network here, and it will be like Polygon, and then the RPC URL will search on internet to get something like this, Polygon RPC, and then there is a chain ID. This chain ID is very much similar to what we have already I have already introduced it to you here. Chain ID is 97. 97 corresponds to BSC test network. BSC testnet, and for Ethereum Ropsten it was 3. For BSC mainnet it is 56. So they are like the a particular ID of is an RPC URL will have a particular ID that just we need to enter. Here the chain ID is 137, and then we can have poly. Okay, then we can save it. Got it. So we do have 0 poly because I don't have any polygon, and polygon coins, and it is now added to my network. So I have now 3 different uh, networks in my MetaMask. But since I'm working on BSC testnet, I'll move on to this BSC testnet. And then there is something called Faucet, and there are websites which will give you fake coins. Those fake coins are of no use apart from testing and development purposes. So I have received 0.5 test coins from somewhere, and then right now I'm having so much of test coins. They have got no real values. Now, after this, there is an option of create account. So we can create account also here, account 1, 2, 3. So you see, now I have 3 different accounts, this and this. So this has nothing. Okay, we can shift between the accounts also, that's also possible. So if there is any activity which has been performed while this MetaMask was connected, so that particular activity will be shown also in your MetaMask tab, this activity tab. But if it is somehow deleted and all, the information is already stored onto the network, which never gets deleted. So this is just the local copy of what is already written onto the network. So we can send it between, transfer different accounts. I'll send about say 0.12 test BNB. So the gas charges which I was talking about is this. For transferring 0.12 test BNB, we'll need to pay about 0.001221 test BNB. And suppose if single BNB has a cost of about $270, so corresponding you'll pay about 0.1 or $0.4. You can calculate this. So that gas fees needs to be paid. Now since this is just the exact copy of mainnet, it's okay, like we don't mind it paying gas fee or increasing the gas fees. But in actual real world, this will matter. Okay, so we can either reject it or confirm it. So I'll just confirm it, and you see the transaction is still pending. So it takes some time. It's asking me to speed up. I'll speed up. I'll increase the gas price to 19. Let's see, and also I'll increase it to 150. Yeah, so it's just okay, but yeah, but it did not the change did not take place, and the gas limit and gas used was of earlier, but it's okay. So get the feel of how the gas prices and gas limits are being used for speeding up the transaction and saying that okay, you do my work first and leave others because I'm paying you more. So we can copy this transaction ID, and then we can move on to BSC testnet to see what happened. We are here on BSC test network, and we can see that, yeah, see 1 minute ago we had this transaction, and wherein we transferred something from this address to this address. So it is also 1 minute ago we have transferred some amount from this 0.12 BNB from this address to this address. So that is what happens here. So the new account will have 0.12 BNB. So we can see that the new account, which is 0.3, is having 0.12 BNB. So that's how we transfer test BNB from one single account to other. And likewise, as we have transferred test BNB, we will be transferring our own coin from one account to another. So that is possible, and we'll be doing that. Now I have shown you 3 things here. I've talked about the networks, the website interface. I talked about QuickNode or Web3 APIs, and I've talked about MetaMask. Now we'll see about IDE, the editor of Solidity. And here the editor of Solidity we use will be Remix. Now the thing is, we do not need to download any software for using Remix and Solidity. It's just a simple web browser. It works on a web browser based UI wherein we can write our own code and compile and deploy our contract. So we'll see that now. So this is how Solidity looks like. Remix ethereum.org. So here we have this the side menu. This is a compiler, Solidity compiler, this deploying and running, and this is for debugging. So we'll first start with creating. So there is some default contracts here. So we'll start first with creating our own, choosing a template. Now there are general default and blank. There is OpenJPLin. OpenJPLin is a very good starting point for beginners because they give everything. It's like a plug and play. In the website also you'll be able to create your own token because they have that facility, and everything is open source. So it is just for creating. They provide all the templates at one particular locations for different functions like burning, minting, creating, or value transfer of the token. So all those functions are already created. You just need to edit your token name and quantity. So OpenJPLin provides all those features. Now you see ERC20, ERC721 and ERC1155. So basically these are different protocols. Just like we have in networking different port number for different purposes, different communications. Yeah, and in blockchain we do have different protocols for different actions. Like for cryptocurrency and all, we have ERC20, 721 maybe. So ERC 721 is for the collectibles and cryptocurrencies where you have some non-fungible tokens, so you can interact with. And similarly 115 is related to 1155 is related to the fungible and non-fungible token transfer. There's in blockchain you'll always come across two different types of tokens, fungible and non-fungible. The one which can be broken into very small numbers or digits, and the one which cannot. Just take for an example, if you have 1, it can be represented as 10 into 0.1 kind of. So you can have a transaction at the level of 0.1 or 0.01. How far your token allows to go to, like the decimal values. In non-fungible, you'll have something, let's say you have a painting of a cat which is very good and generated on stored on the network, so that cannot be like shared across a number of users. So that has to be a unique and a single copy. So that's the non-fungible one. So you'll come across these two. But what we are doing is in the fungible section where we are able to transfer tokens, and here we are not doing anything on collectibles and arts or anything kind of. So the last is ERC20. We'll be starting with the blockchain project. This ERC20 will first create a workspace. So it has a contract, it has deployment scripts, and it has tests. So this particular function is called from here, the contract one. So we'll first look at the sample ERC20.soul. .soul is for the Solidity. See, so there are option. I clicked on this and it compiled also. So let's see. Contract ERC sample ERC20 as ERC20 token. So this is the way it is said. It can be said that is sample ERC20 contract which we are defining is a ERC20 type protocol, and here we have three different public numbers: name, symbol, and decimal. Name is again name of your contract. Symbol, what do you want to give shorthand notation, and decimals. How small will be able to divide it to a number, like generally it is 12 or 18. So 1 raised to power of minus 18. If you have one coin, you can transfer about 1 raised to power of minus 18. But remember the gas charges. If you transfer such a small amount of tokens, you need to pay a very huge gas charges. Yeah, maybe more than 1 raised to power of 12 or something. Correspondingly, like if you want, take for example Bitcoin. Its price was at one time about 80 lakhs or 70 lakhs. So there, and it decimal has, if its decimal has 10, so you will be able to transfer 1 or 2 like 80 lakhs. So 1 or 2 rupees of equivalent to Bitcoin. If it decimal was only 4 or 3, then you'll not be able to transfer 1 or 2 rupees of Bitcoin, and you'll have to at least transact thousands and 10,000 rupees of Bitcoin. So that's one case of use of decimals. Secondly, if you transfer 1 or 2 rupees of Bitcoin, you'll have to pay gas charges, and that gas charges will be 100 or 200 rupees. So for transacting 1 or 2 rupees Bitcoin, you'll have to pay like 100 times the gas charges. So that again determines how much minimum amount of coins you need to transact. So here the decimals constructor and total supply. Yeah, total supply is something. What's the number of circulating coins you want to be in the network? So this is again important, because we can print or mint money in the physical cases, but here in Bitcoin we'll have to provide it. Do we want to mint it, the money or the tokens, or we just can fix that this particular Bitcoin, this particular coin will not have more than so many number of coins, let's say 10 lakh coins or 100 lakhs coins. So similarly, the Bitcoin has the option of minting, and it has a half-life. Like for first 10 years, you'll be able to generate so X number of Bitcoin every 6 minutes. Then it will be generated in every 12 minutes from after 10 to 15 years, and then after 15 to 20 years, it will be generated every 24 minutes. So you are decreasing the half-life of generation, and by the end of 2040 or 2045, you will be exhausted with all the Bitcoin. Like all the Bitcoin will be in circulation. So you can do that way, or you can just fix the value and flow circulate all the coins in the network. But so in that case, mining is not possible, because since already it is circulating in the network. So this is how it is. Now let us copy one such. So this is a very simple one. The Pragma solidity, you see, this is 0.5.9 is the version number. So of this particular IDE. So let us copy one and see the complete picture of the solidity. Okay, I have this complete picture I have this complete code of which has this all the information from the deployment point of view. The sample ERC which we just saw now did not have its own like minting, unburning, or transfer functions, but we need to provide that. That's what is completely written here in this particular Solidity program. So you see the Pragma version, we are working on the more latest version, and interface is IERC20, and we have a function of total supply, we have a function of balance of address. See, this particular function will be using in our code. This also we can use, but will not be using now. And transfer hash. So we'll be using this particular function also, like for transferring the number of tokens from one account to another. And you see external, so these can be called externally also, and it will return integer values. Then yeah, the allowances value approve, like do you want to approve. So we'll see one such case where we will be approving the transactions transfer from. So we'll have three different things here: sender, recipient, and amount you need to transfer. So whatever we are doing in the blockchain is defined by a transfer functions. Is defined by a functions. For transfer we have a function. For approving we have a function. For determining balance we have a function. For burning, for minting, for everything we have a function here. So and then again for name you have a name, you call it by a name. So for that it has a function. For symbol it has a function, because just see we have created name and symbol, but just writing name and a symbol in sample ERC will not serve the purpose, because somewhere in the background we need to define functions also corresponding to each variable. So decimals. Now we need a message sender. Yeah, if we need to assign any message also, so that for that particular thing it is a message sender and all. So we'll see. Yeah, a mapping is a function where a particular account will have so many number of coins in integer value, and it will have the private total supply, private. So this is for the metadata purpose and all. So this is again the constructors. I'm just going through, see the decimal. If in decimal when this function will be called, it will have 18 decimals by default, but it can be see it can opt for 18 decimals unless this function is overridden. So total supply, return total supply is another one. Balance, yeah, when you will be doing get user balance, so we'll be calling this particular function. I'm going through all the important functions which we deal with in regular life, and not the one which has very specific purposes. Yeah, if current allowance, that current what you want to transfer, so we'll have to, this require function is for like this condition needs to be followed. Require is a keyword where this condition needs to be followed when you are transferring from one account to another. You need to see that the transfer amount is not greater than the available amount, or it will throw an error. So allowances sender and message sender. Whatever the message sender is asking for, if it is greater, then it will throw error. Then increase allowances, decrease allowances. So you see that basically the increase or decrease allowances is for, see, allowance is for transferring the amount of money or token from one account to another account. So the one who transfers the money will decrease the token balance, and so decrease allowances, and then it will be increased for the one who receives it. So that particular function defines, so you need to upload those values of tokens in individual account. Similarly, there is an option of this transfer. Yeah, the sender is not recipient 0, address 0. Address 0 means your account is someone can. There was a case also a few years back when the token present in a contract was sent to 0. 0 means dead. You cannot recover it. So when the sender is not equal to 0, then only you do these particular transactions. This so as to ascertain that someone does not send your own token to 000 account, which is the dead account. You will not be able to recover or generate from 000. That is the minting account. For generation, it is the genesis, and for burning, and then if you want to send, then that's called the burning processes. So transfer and transfer hash is the hash value. So say the mint account mint to the 0 address. So it has to be minted, and I'll show you while minting. It says that from 00000, so the number of contracts, so many number of tokens has been generated and transferred to so and so account. So that's the process of minting. Burning account, you can transfer that generated token to 000. That is the number of tokens in the network is reduced by the amount you have sent to by the amount you have sent to 000 address. So approve this again, the same function before token transfer hash, after token transfer hash. See, this is a complete long code. This is again the same thing with the individual value burn from. They have got each and every detail, so you may need to understand or just work with the main functions and leave. A lot of them are by default, and you can leave it also. But for being a Solidity developer, you may need the expertise in understanding each of these functions and how do they work. And finally, we have this math functions also, where you do all those calculations so that it is not overridden by some malicious user. So they can change the value of this average by doing some multiplication and division if it is not defined in your code. So this is again okay. Yeah, you can have the option of pausing your mint facility, and then when not pause, you can have this the when pause, you can then unpause it. Then you can grant roles, set admin role, like you can have address perform all the transactions. Like initially, if you were an admin, you can transfer that administration rights to someone else, or you can revoke. If you are also admin and someone else has some extra privilege, you can revoke that also. So you can by default renounce your role, and it can become a community based coin. So there are a number of coins here, or contracts here, that they revoke the their ownership to they revoke their ownership in order to gain trust from the end users or buyers and sellers. So finally, I will come to here. Finally, I'll come to here. Contract. I have a where token is a ERC22, ERC20 burnable, snapshot, access control, pausable, and ERC. So we don't have that minting facility. ERC20 mint is not there. So whatever the functions you saw earlier of those, these are the options which we are providing to our verification token. So I'll first change this contract name. vary token. I'll do this vary token, and I'll then again give a shorthand notation working ERC22, and then set up rule default admin message sender. So message sender is the contract address who will be deploying this particular contract onto the network. So an initial mint is of about so many number of coins. So we can do again, I don't know, 4. So 10 raised to power of 18 it is. Double means that it is to the power of double multiplication means it. So the message sender, which is the contract address will be deploying, will have all the rules and will be able to receive so many number of coins after deploying this contract. So let us first compile this contract. It's already compiled, but then again we'll compile it once again. We'll change this to 8.4 corresponding to this, and we'll change it to this. At first we'll need to change the name. The name is vary token.show, and this names come from here, vary token. So you need to be sure that whatever token you are using has the same name as is given in contract name, should be named with the file name. Okay. So once I do this, I will compile this. Vary token.show, and then I will do a deployment. You see, this is the very important and the last step of deployment. We have understood this functioning of this Solidity code. We have understood the deployment. We have seen in detail what each functions do, and the most important is we need to define functions for each operations. That's the most important point. So there are different environments. These are the virtual machines, Remex virtual machines, and then we'll have this injected provider MetaMask. So this needs to be set up, and that's the reason we have initially set up this MetaMask. So once it is set up, we'll just click on this, and see, this is custom 97. This is the chained ID, and I already have an account linked with this MetaMask with 0.103 Ether it says, but it's actually test BNB, and we'll then select the token and we'll deploy it. Let us see what happens. So first this will ask for approval of, I'll be spending so many amount of TNB. This is all test BNB. So first I'll see what's my current default account. I have this account, so I'll connect my B8E. Yeah. B8E. I'll connect any one of those. CF6. So this is connected. Now I'll deploy, because we may have different accounts and addresses, and it may be linked to one single address. Now we can do this. So see, that particular thing is gone, that you have selected different account and you are working with different accounts. So we'll just confirm this, and here I think we'll get. So congratulations, our contract is now deployed, and it has taken so many number of gases. Transaction cost of this gas, so you can calculate corresponding test BNB for this, and transaction hash is this one, and it was from this particular account, this account, so many number of tokens were generated. So these are the log files. You might have seen this. V is the smallest uh, V is the smallest unity quantity in which it can be transferred. So we will first look for the transaction hash onto the blockchain network. We are here and we'll see this blockchain network, and you see this. So you can see this just now, 1 minute ago we have a transaction wherein we have from this particular account we have interacted with this contract which is created, and from 00 genesis we are able to achieve or receive so many number of Veri token coins, and the gas charge is the same, which is like this and shown there in the nonce positions for the address there, so on which it has occurred. So we can see now this particular transaction hash is stored will be stored in this particular blocks. So we have the log file, and this is the log file which is generated for this transferring. Okay, this is not for the transaction receipt events, but it's not for the transaction. So what we have seen is we are able to generate and deploy. Now there is one more very important thing. We have this contract, but it's unverified. You see, you don't have a verified contract. Now this here lies everything. The scammers and all the functions which I have written needs to be known to the public, because if they have to trust in your network or the contract, they must know that if you are doing a transfer of 100 coins only, it will only transfer 100 coins and not 100,000 coins or empty your wallet, because a transfer is one function, but what is happening inside that function is there's something like the contract deployment is defining. So the end user must know that the function is that the contract is verified, and they must be, if they are not like Solidity for them may be new, but there may be someone who has expertise in the field to read and understand the different functions, and they may pin out that this particular contract is deployed with a malicious intent of emptying your wallet. Or the second thing is also, like, if you have this verification, then anyone can audit your code, and that's again the most important thing in blockchain network code editing or the contract editing, so that you don't have any unwanted or undesired bugs in your code, and that can be done in open source. Like, anyone can do that auditing in order to understand what is happening. So we'll first verify and publish our contract, and if it is not verified and published, we'll not be able to interact with this particular blockchain network also. It will just be using for transferring the account, and all those functions will not be able to see what is happening behind, and will not be able to interact with the APIs from Infura or Qcloud. Well, first we have Solidity single file, then we have MIT license, and we have a compiler version of this. So here I'll put all my Solidity code which I have written. So this is my complete code. It has everything, like all the functions are shown here. I'll just do, I'm not a robot, I'll verify public. So let's see, it should not generate error, but many a time it does, and it's very hard to debug of what goes wrong. Congratulations again, your contract is verified, and now you'll be able to interact with your contract using Web3 API. So the contract was created during this transaction hash, and it has been bytecode and ABI for the has been successfully generated. So this is very important. Now we'll go to the contract address and we'll see this. The contract, this particular green signal is shown here because anyone can read contract and anyone can write contract. So these are the options which I am providing. These are the options which I am providing. Earlier this was not shown because the contract was not verified. Okay, so these are different low severity, medium severity. Now what we need to do is we need to copy this ABI for our software, for our web portal to interact with. So we'll be exporting the JSON format because Python reads this JSON best. We're just copying this JSON and we'll move on to the Visual Studio Code for the next thing. So here we are in Visual Studio Code, and this is our ABI function. If you see, this is the same format, and this function was from the earlier Opston network, but earlier tokens contracts. Now, since we are able to deploy a new contract, we'll be just replacing it. The new ABI here in this format like this. So once it's done, the ABI is now generated. Now we need some other things also for it to work, because we have said that we need to update this contract address. This contract address is here. This is our contract address. We'll copy it, we'll paste it, and this is our deploying addresses. And this is again using this particular. This will be same. There is no issue. So here we can see we have this. This is the same, establishing a connection, calculating the decimal values using decimal function, then a balance of this account. If that balance is greater than 1, then we can have this transaction happening. So that's how. I think we are now set to go. There's just one more thing remaining. It's about generation of your grid file, grid.json, that we'll see now. So this is our the grid generation script. Just a simple, very simple script, and this will not be on the web portal because that's something very specific, and we need to treat it in the back end. So for registering, I'm doing this one. Click on this register. You can have any name. Let's say it is ABC. Okay, then we need to provide the public key. Public key is this. This is public key. So click to copy to clipboard. This is public key. We'll be copying this and pasting there. We have pasted the public key. Now we'll paste the private key. This is my private key, and I will paste it. It's 65 characters long. I'm only showing a part of it, so I'll just do OK. If you want to save the wallet credentials, so this is the same password which was being entered onto the profile page, so we can enter a password here. I'll say yes. My password is II. Done. So we can now move on to next. Like we have now grid.json file. We have everything set up. We'll move on to the next part. We see here the grid.json file has this first and second value. All the information stored of the public, private, and the password and the name in this particular file in encrypted format. So we'll first run our server and upload this file, login and upload this file and the PDF file. So here I'm running my server, you see, and yes, my server is now running. I'll log on to the server. So this is I'm on my server, and you see this is the same thing as discussed earlier. So we'll just be going into this login, and then I'll type my email ID and password here. So we are now here in our profile page. We'll upload a PDF and a copy of our key. So here we'll upload this our PDF, let's say 2.pdf, and a key, and the key is this one, the latest updates, and the password is I will submit it. Congratulations, your document has been signed and transaction hash stored onto the new contract which is being deployed just now. So the signing authority is PO, the document hash is this one, the transaction hash is this one. We'll look these one by one. So first we'll download it here, we'll open it, and this is our new barcode which is generated. Then we'll hop on to our we'll move on to BSc testnet and copy this. Actually I can provide a link later on. You just open this from here only. So I am here, and you see just 57 seconds ago this particular transaction took place, and from this account to this contract of 0 value, and the most important thing is this was the hash value, AD 965. You can see 965 AD2 T3, 965 AD2 T3. So that's how we are able to generate on a new network, and the network which we can see here is this. Very token, and you will see that just 1 minute ago this particular transaction took place, 0862 086. This transaction occurred, which is shown here, and this particular block, and from this to this particular contract address, from this address to this address, and it costs about so much test BNB. So I think that's it. See, the transfer hash function has been called here, so people can see which function has been called: role granted, transfer, and then role granted. Now we can verify this signed document also. That's also possible. So we'll verify this particular signed document just by uploading this. I'll choose this file, and then I'll submit it, and you can see 965 AD2 D3. That's all. So we have seen a lot, starting from the development, deployment of contract to all the things, and everything is done on a testnet. On the mainnet, BSc mainnet will be doing a similar tasks. Like we'll be connecting to the same network, to the same address, but only the thing is we'll need to pay real amount, real gas charges, and to the BSc mainnet. Okay, so that would be the only difference. Every other thing will be very much same. Okay, so now we'll meet in next lectures. I'll summarize the learning of both the two lectures, and give a summary, and go through one by one, go through the bullet points detail of all the work which we have learned. Thank you.